I'm going to make a video showing how to write the vertical velocity and vertical displacement equations. I know you have a homework assignment about that. Actually, let me change this: vertical velocity and vertical displacement equation. So you have a homework assignment over it. Several of you were confused in class today. So I'm making this video so you can see an example of how one's written out. First of all, let's start with the vertical velocity equation itself. Vy is Vyi plus gt. So a relatively small, simple equation. In this scenario, there's a bottle rocket. Alright, I can't. Alright, so you got the bottle rocket here. And it's going to be fired at 70 degrees. So we know that it's going to be fired at 30 meters per second. So this is a little vector here. And the angle is 70 degrees. I have a lot of information here. But in this problem, we only care about the vertical displacement and vertical velocity. So we really only care about the vertical component of this vector. This side of that triangle right there. This is what I'm concerned about. And we discussed earlier how to find it, but every time you're trying to find the vertical component, so if you see an angle, if you see the angle, that's really the key to tell you that you're going to have to find the component. The vertical components will be discussed before. Vyi is going to be V times the sine of the angle. I should have had my calculator. I have to get my calculator. Alright, I have my calculator now. So what I've got is the velocity here is going to be 30 meters per second times the sine of 70 degrees. So I'm just going to punch that in on my calculator. 30 times the sine of 70. And I get 28.19. I'll round it to 28.2 meters per second. This is really the only velocity we care about. It doesn't need the other part. I could find it at 30 times the cosine of 70. The other part ends up being 28, so you can tell that excuse me, I did it wrong. 30 times the cosine of 70. The other part should be really small, right? I mean, it's a pretty steep angle, and it turns out the other part is only 10.3. So this side would be like 10.3. But I don't care about this side, right? It doesn't matter how fast it's going over. We only care about the vertical motion. So moving on, Vy is going to be equal to Vyi. Well, we just figured out what that was. That's 28.2 plus G is negative 9.8 times T. Now, when we write these equations, you're just going to leave T in as a time. So what we've written here is really, in math class, you would call it velocity as a function of time. And we wrote an equation for this situation says that velocity is going to be the velocity any time. To get that velocity, you take negative 9.8, you multiply it by the time, and then you add 28.2. That's really it. That's all I want. This is my answer, even though it doesn't really look like, you know, a traditional answer. This is what I'm looking for. If I plug in a time, it will tell me that velocity. Just for an example, really quick, let's figure out the velocity of 2 seconds. Now, you're not required to do this on your homework. I just want to show you how it works. Well, this is going to be 28.2 plus negative 9.8 times 2. And if I put that on my calculator, I get 8.6 meters per second. So again, this means that after 2 seconds, this object's going to be going 8.6 meters per second still. At 4 seconds, it's going to be 28.2 minus 9.8 times 4. So at 4 seconds, I end up getting negative 11 meters per second. So see, it's going down at 4 seconds. So we could actually even try to figure out, okay, somewhere between 2 and 4 seconds, maybe at like 3 seconds, it's going to get really close to the peak where it'll be at 0 meters per second. But again, this is powerful because I can plug in a time and I automatically get the velocity back out. Alright, so let me erase some of this stuff here. I'll keep this here because that's important. I'm going to go ahead and erase this. So if you're taking notes, you can pause the video right here to get this down before I erase. Alright. Now I want to write the vertical displacement equation. So this one's a little bit more difficult. If you can write this one, you can really write any of them. The vertical velocity is easier, I think. Alright. Alright, so the vertical displacement equation is going to be yi, the initial height, plus the initial vertical velocity again, so it's really important you understand how to get this piece here, because it's going to go there, times t plus gt squared over 2. Now, there is no initial height given here. So anytime this happens a lot, you're just going to put in 0 for the initial height. So 0 plus the initial vertical component velocity is 28.2 times t. Sorry, let me describe again. This is the same thing as that. We only care about the vertical velocity. Notice that I'm never using 30 after this part right here. I use 30 right here, and then I never use it again, because I just don't need it. At this point, I only want the vertical piece, so I'm only care about the vertical piece. And once I have that, that's going to go here. All right, plus times t, plus g is still negative 9.8 t squared over 2. Well, I can simplify a little. I'm going to drop the 0 because I don't really care about 0. So I get 28.2 times t. And I can go ahead and take negative 9.8 and divide it by 2, and I get negative 4.9 t squared. Again, it may not look like it, but that's what I want. That's the answer I really care about. It's supposed to be a y. So this, again, describes the height. This describes the vertical displacement or the height at any time. Quick example. Let's say I want to know, you can think of it as, what's the height? So this represents the height as a function of time. That's how you would phrase it in your algebra class probably. 28.2 t minus 4.9 t squared. So let's say I want to know, okay, what's the height at 2 seconds? Alright, if you remember from earlier, at 2 seconds it was still on the way up. So it's still moving up at 2 seconds. And if I did that, I get 28.2 times 2 minus 4.9 times 2 squared. Make sure you're only squaring the 2, and you square it before you multiply. You got to do your order of operations there. So 28.2 times 2 minus 4.9 times 2 squared. And I got 36.8 meters. So that would be the height after 2 seconds. What about the height after, let's do the height after 5 seconds. Yeah, just another example. 28.2 times 5 minus 4.9 times 5 squared. 28.2 times 5 minus 4.9 times 5 squared. And I got 18.5. So you see it's on the way back down here. Here it's going up, and then it goes back down. Of course, if we graph it, we get a parabola. We talked about that in class. If we graph this equation, you get a parabola. It opens downward because it has a negative coefficient on the squared part. So t squared is negative, and it'll always be negative, right? Because g is going to be negative 9.8. So when you graph that, you end up just a quick sketch here, something like this. This one actually intercepts. It starts at 0, and so it will go up kind of like this, and then go back down. And we even figured out, remember we said around 3 seconds is probably going to peak. You could actually figure, later on we're going to figure out when it actually gets to the top, but we're going to figure out it peaks around 3 seconds. And it probably hits the ground at about 6 seconds. I'm guessing if I did 6, it'd be pretty close to the ground. Actually, I'm going to do that real quick. 28.2. See, this is why I'd say you can use the equation really easily. It only takes a second. Minus 4.9 times 6 squared. And sure enough, as long as I didn't mess up, at 6 seconds I got negative 7.2, meaning it's actually already hit the ground. So like I said, it just gives us a rough approximation, and soon we're going to be looking at it in more detail. So I hope this helped. Again, the only other thing about the homework is if I don't tell you a height is 0, also the same thing if something gets dropped. If I'm dropping an object, then the initial velocity has to be 0. Thanks for watching, and encourage your friends to watch this video if they haven't yet.